Hello, here's another AQA A-level Physics multi-choice question. This one in the topic area of diffraction and refraction interference. If you want to do a similar question on the same topic, click on the information card here. If you want to do this question, I suggest you pause the video now. If you've got the answer B, well done. Okay, so monochromatic light, that means light of one wavelength, is incident normally on a diffraction grating that has 4.5 times 10 to the lines per metre. The angle between the second order diffraction maxima is 44 degrees. So what we've got is, we've got our grating, the light is shining at that grating, the light is going to be diffracted and then produce an interference pattern of bright and dark spots on a screen. So the spot that is straight through is called the zero order, then we have the first orders, and then as we go further out we get the second order maxima. Okay, so the equation we're going to use is from your data sheets. It is D, which is the spacing between the fringes, not between the fringes, between the gaps in the grating, times sine theta. Theta is this angle here between the normal line and the line between the grating and the nth order maxima. And that is equal to the number of order multiplied by the wavelength of light, which is what we're trying to find. Now, there's a couple of things that make this slightly tricky. First of all, you're not told the spacing between the grating, between the lines on the grating. What you're told is how many lines there are per metre. So I can find the distance by taking 1 over the number of lines per metre, and that will give me the number of metres per line. So that gives me an answer of 2.22 times 10 to the minus 6 metres between each of these lines. Very, very small number. The other thing that's a little bit tricky is this angle of 44 degrees isn't this angle theta. It says it's the angle between the second order diffraction maxima. So what they've said is this angle here is 44 degrees. So theta itself is 22 degrees. So I've got everything I need now to use this equation. I'm going to rearrange the equation to make the wavelength the subject, and the wavelength is equal to the distance between the lines on the grating multiplied by that angle theta over the nth order, which in this particular case is going to be 2. So let's put some numbers in. 2.22 times 10 to the minus 6 meters for the distance between the lines on the grating, multiplied by sine of 22 over, it's a second order, over 2. If you put all those numbers into your calculator, you'll get an answer of 4.16 times 10 to the minus 7 meters. Well, that's the same as 416 nanometers. The answer is B. I hope you found this video useful. If you did, give me a click on that subscribe button, watch some more of them, share them with your friends, maybe even press that like button. Thank you very much.